Let's look at the basic connection chain that brings AV over IP to life. First up is the device that makes the network possible, the network switch. The switch sits at the center of every AV over IP system. All devices and connections in your design plug into it, making it the heart of the setup, the place where all the data flows through. And when it comes to cabling, it's simple. Everything runs over Ethernet. The easiest way to imagine the switch is like a post office. Every piece of data it receives is like a letter with an address on it. The switch checks the address and ensures the letter is delivered to the right destination. That way, every message arrives quickly and exactly where it should. We'll dive deeper into the network switches later. For now, this is all you need. On the left side of the switch, you'll find the encoder, also called the transmitter. This is where your source device, like a laptop or media player, plugs in. The encoder basically takes the raw AV signal from the source and converts it into network data, since that's the format required by the network. It then sends that data straight to the switch using an Ethernet cable. On the right side of the switch, you'll find a decoder, also called the receiver. This guy connects to your display device like a TV, projector, or LED wall. It receives the network data from the switch and converts it back into standard AV signal ready to be shown on the display. Now, one quick note about encoders and decoders. As I already mentioned, we can also refer to them as transmitters and receivers, or simply endpoints. It's all interchangeable. Just something to remember as we go along. The next piece, and the most important one, is the controller. It's the brain of the entire system, allowing you to design, manage, and control everything in your NHD project. To talk to the other devices, the controller must also be plugged into the network switch. The entire project is stored on the controller. It includes system settings, encoder and decoder information, firmware update settings, API commands, log files, and more. Another important job for the controller is routing signals. It decides when and where each stream should go. For example, it might say, encoder 5, send your stream to decoder 7. Or it might say, encoder 5, send your stream to decoder 7, 8, and 9 at the same time. No matter the size of your design, big or small, the controller is always essential. Without it, there is no way to interact with the system. Finally, we got a laptop. It connects to the network switch with an Ethernet cable and gives you access to the controller's dashboard. No special software is required. You'll access the controller through your browser, so it doesn't really matter if you have a Mac, PC, or something else. If it has a browser, you're good to go. Just remember, again, the whole project lives on the controller itself. The laptop is simply your window into the system, a way to log in and tweak settings whenever you need to. Now that you know all the puzzle pieces, let's see how they fit together from start to finish. So picture yourself as an engineer sitting at your laptop connected to the network switch. You're accessing the controller's dashboard, and with a single click, you route the signal from the encoder to the decoder. On the left, the encoder takes the raw AV signal from the source device, converts it into network data, sends it to the switch. At the center, the switch manages that data and directs it exactly where it needs to go. On the right, the decoder receives that network data, converts it back into standard AV signal, and sends it to the display. And just like that, you've got a picture on the screen. And this really is the whole idea of AV over IP. Once you understand this, expanding the system is easy because the architecture always stays the same. Let's check it out.